Good afternoon. My name is Carl Hughes. Today is May 27th, 2018. Today we're going to talk about proper bit selection to prepare wood for installation. This is part of carpentry, and specifically interior finish carpentry. Okay, so we're going to talk about four basic types of holes. There is a pilot hole, a clearance hole, a clearance hole with a countersink, and lastly, a clearance hole with a counter bore. Here's how they work. First of all, if we were to take a screw, the screw would thread into the pilot hole so that the threads of the screw actually thread into the wood. That's for when we want to control and connect with this piece of wood, not the one behind it. The clearance hole, a little bit different. It means that the entire screw will fit and clear through the wood so that we can fasten into something behind it. If we add the countersink, that's to allow the screw and the screw head to fit flush or below the surface of the wood. And lastly, with a different type of screw, namely a hex head, which has a different type of head and a flat bottom, we would like to drill a counter bore so that the entire head of the screw fits down into the hole and below the surface of the wood. So if we were to follow the book, the guidelines for a number 8 screw would be, in hardwoods we would need a 7/64 bit. Then if we were to go into softwoods, we would need a 5/64 bit. One is just slightly less than the 1/8 of an inch, that would be the 7/64. The other a little bit smaller. And that's because the hardwood is harder to bite into. If we were to make a clearance hole, we would need an 11/64 bit. But in practice, we actually do something entirely different. We actually select the screw, and then we take a bit that is fairly close to it, and we compare the screw up against the light and see if the bit is slightly smaller than the threads of the screw, just about the size of the shank of the screw. So first, we're going to talk about the use of a pilot hole. For example, we may want to attach a piece of hardware to a piece of wood. Very simple, but we don't want to split the wood. That would defeat the purpose of making the hole. So what we're going to do is to drill a pilot hole to accommodate the screw, and then we won't split the wood. So we would like to attach this small piece of hardware to this piece of wood. And what we're going to do is take the appropriate size bit, drill the hole, and then we'll attach the screw and the hardware to it. Now, the next thing, we're going to take our drill with the bit that we talked about before. We're going to drill the hole. And this will accommodate a number 8 screw into the hole, and then the screw will fit tightly into the hole and secure the hardware. And so when we're finished, the wood doesn't split and the hardware is secure. According to the book, we should have an 11/64 bit to drill a clearance hole for a number 8 screw. That would allow the screw to pass clean through this piece, clear through this piece of wood, and allow it to fasten into something behind it. But in practice, what we do is we actually select a different bit, and that bit's going to be close to the size of an 11/64. However, what we're going to do to select that is to just simply take the bit and the screw together and make sure that our bit covers that screw completely, including the threads of the screw. The reasons for a clearance hole. Well, there's a couple of reasons, actually more than that. Number one, we don't want to force the screw through the wood. It's difficult, and usually it ends up stripping the screw or damaging the wood. Number two, if the wood threads into this and it splits, that defeats the purpose of having a clearance hole, or defeats the purpose of actually screwing the two pieces of wood together because the screw won't hold. The third reason that we want to make a clearance hole is that as we thread this screw into the first piece of wood, when it comes out the other side, it's actually stronger in the first piece of wood, and thereby it separates the two pieces of wood from what we're doing instead of actually connecting them. So we want the clearance hole through the first piece of wood, and as we do that, that allows the screw to thread into the second piece of wood. And now to drill a clearance hole. First of all, we put on our safety glasses, and as we had said before, we're going to select a bit that will clearly cover the entire screw, including the threads. We're going to take that bit and drill into the first piece of wood. However, we're not going to drill into the second piece of wood. We're only drilling through the first piece. This way, when we put the screw through, it will go clear through the wood, and hence the name clearance hole. What can be done is to drill a pilot hole in the second piece of lumber, and thereby when we do that, this will allow the screw to thread into the second piece of lumber, but not the first, and thereby we would get a good fastening. So now we take our screw and we're going to put it into our clearance hole. It will fit clear through the piece of wood, and it will thread into the second piece of wood. And the idea behind that is we'll get a good fastening from this piece of wood to the one below. Clearance hole. Now, as you recall from before, we talked about a countersink hole and a counter bore hole. The countersink is for a flathead screw, and it allows the flathead to sit just below the surface or flush with the surface of the piece of wood. This is very important, especially with hardwoods, because very often if the wood is hard, such as maple or walnut or something like that, then it will not be easily forced into the wood fibers. The end result is you strip out the screws. The counter bore is basically the same idea, except when we use a flat-bottomed head, such as a pan head, or in this case a hex head or a hexagon head, we would like the pressure of the head of the screw to press down equally all around on that piece of wood. So in our case right here, what we're going to do is in this type of hole, we're going to set for a countersink because we're going to use a flathead screw. And a countersink gives us a V-shaped cut into the top of the hole. So in order to drill a countersink hole, that will usually be done after the primary clearance hole or pilot hole has already been drilled. You can do it with a separate bit, and right here we have a selection of countersinks. We would take one that is appropriate to the size of the head of the screw that we are using. In this case, it would be about this size countersink would work well. This would give us an appropriate size countersink. However, these are often sold as a combination bit, where the main hole is drilled with the bit and the countersink is built into. It's called a combination bit. Now, as you can see, I've already drilled the clearance hole for the number 8 screw, and I've already selected the appropriate sized countersink bit. And all we have to do is to drill this hole just enough so that the actual head of the screw can go into that hole. A quick way to check is to just take the head, reverse it, and if it's exactly the size of the screw head, that's great. The important thing to remember with a countersink, it's countersink, not counter bore. We do not want to drill too far into that piece of wood. And there we have it. The screw should be just below the surface. Now, last but not least, let's talk about a counter bore. A counter bore simply means we're going to drill a clearance hole just big enough for the head of the screw. So it's only going to go down into the wood about as tall as the head of the screw. So in this case, that would be maybe 1/4 inch to 3/8 of an inch into the piece of wood. This will be done by selecting a bit that is just slightly larger than the actual head of the screw. We could use a spade bit, sometimes called a paddle bit, or we could use a Forstner bit. The Forstner bit will give us a smoother hole, but it's okay if you use the paddle bit or the spade bit. That still works just fine. So what we're going to do is drill into the first piece of wood just enough for the head of the screw. In this case, about 3/8 of an inch down. And so, safety glasses, Forstner bit, and drill we go. And that's our counter bore. Once we've done the counter bore itself, now we're going to drill a clearance hole all the way through both pieces of wood. Take our clearance bit hole, clearance size bit, and now you can see that the clearance hole goes right through both pieces of lumber, and that's enough so that we can put the bolt through, and it's just below the surface of the wood and goes all the way through both pieces of wood. And now, I'd like to thank you for spending time with us today. We've been able to discuss all 4 types of basic holes: pilot hole, clearance width, countersink, and finally, last but not least, our counter bore. Thank you.